Hi guys. Okay, so let's look at the homework problems for chapter 9, which is on solutions. And in this video, we're going to cover two homework problems, number 9 and 29. Okay, so number 9 deals with a balanced equation for the dissociation of electrolytes. So here we have the first two examples I've taken is the C and D, the rest of it you do yourself, and that is potassium phosphate in 1. Okay, so first of all, potassium, group 1A, soluble in water. So this is going to ionize 100%. Second thing you need to remember that phosphate, you need to remember this is memorization, has -3 charge. Group 1A, elements, all of them have +1 charge. So potassium will have +1 charge. And remember, when we did the, like the nomenclature, so here is, you know, this number comes here and this number comes here at the base of potassium, but we do not write for 1. So that is why the formula is K3PO4. So K3PO4. And so by default, Group 1A elements are all soluble in water. So when we say soluble in water, that means they will all have this subscript aqueous written under them when they split in the water. So potassium phosphate is soluble in water, that's KAQ, and then it breaks up into 3 potassium ions, with each with +1 charge, soluble in water, AQ, and 1 phosphate ion, PO4, -3 charge on the phosphate ion, and that is also soluble in water, AQ. Okay, so this is how you will write. Next question, iron nitrate. Now here, iron, you know, exists as +1, +2, and iron also is +3 state. So how do we know when iron is in +3 state? Remember, it's the crisscross. Nitrate always has a -3 charge, -1 charge, sorry. Nitrate is always -1 charge. So remember, in the crisscross, iron, that 3 in the subscript of nitrate that you see, where is that coming from, that 3? Where is that coming from? That's coming from iron. +3 charge. So remember that this +3 charge nomenclature is here and this 1 is here, and for 1 we do not write. So in this crisscross we have iron in a +3 state. So let me write this down, iron nitrate. And remember the rule that all nitrates are soluble in water, or anytime nitrate attaches to anything, it becomes soluble in water, so it's always aqueous. Okay, so that means FeNO3 whole thrice is aqueous, it's soluble in water. So it breaks up into 1 Fe with +3 charge, and that's aqueous, and there are 3 nitrates, NO3 charge, each with -1 charge, and that is aqueous. So this is how you're going to write iron nitrate, which is iron 3 nitrate, or ferric nitrate, will give you 1 iron +3 charge and 3 nitrate ions, -1 charge. So things that you need to memorize is, you know, the charges on the polyatomic ion, these are standard, they don't go away. So that is what it is. And this is also nitrate, standard, this won't go away. Okay, iron can have +2 and +3 charge. So this is something that you need to now figure out, whether it's +2 or +3. But this number tells you that it is the +3 charge right here. Okay. Now potassium is in group 1A. Potassium is group 1A. So group 1 is all +1 charge on group 1A. And all group 1As are soluble in water, so they're always aqueous. Okay, all nitrates are soluble in water, so they're always going to be aqueous. Okay, so this is how, you know, you will have to, there are a few things you need to memorize, especially the polyatomic ions. Okay, next thing that you need to memorize is, and I'm going to put it here, is memorize polyatomic ions. Okay, and the charges, right, on all general charges on the according to the periodic table, but at least polyatomic ions, you really need that. And second thing is the solubility table. So this we covered in the lecture completely. So now you're going to refer to the handout in, if you're still like working on it. So here we see that all chlorides are soluble in water except, so some of the exceptions are, let's put this here, exceptions to the solubility. So in other words are gastrobar. So this is calcium, strontium, and barium. And then mol, mercury. So that's Hg, mercury, silver, and lead. Okay, so gastrobar and lead. Gastrobar and mol, sorry, gastrobar, gastro. So where is the bar? The bar is located in the mol. Okay, so just to remember this. Okay, so mol, this is just a little mnemonic to remember this. So these exceptions with these are that these calcium, strontium, barium, mercury, silver, and lead, these guys can be partially soluble or insoluble. So here's the thing that all, so first of all, and this group 1A, so this is lithium. Lithium is group 1A. So anytime group 1A attaches to something, it is soluble. So this molecule is aqueous. This will be soluble in water. Silver chloride, all chlorides are soluble in water except, see, Ag. So this is an exception, silver, solid. All carbonates are insoluble, right? And gastrobar, barium falls in that exception of solubility. So this is solid. All right. Potassium oxide. Now oxide, since oxides are not on the table, but potassium is in group 1A. So soluble, aqueous. Okay. Iron nitrate. All nitrates are soluble in water. So anytime nitrates attach to anything, they will make it soluble. So these are the basic things that you need to remember. So that, yeah. So keep this in mind that, I gave you a list of things to memorize. So please memorize those, then it will become easy. So in our next video, we are going to look at the net ionic equations. Okay. All right.